Hello Year 10. Today we are going to be finding the equation of a line, of straight lines. Before we do, we're going to quickly revise the sketching of straight lines that we were doing last lesson. So question 1 asks me to sketch a line using the x and y intercepts. So to do this, I draw up a little table to find my intercepts, and on one half I sub in when x equals 0, and on the other side I sub in when y equals 0. Okay, if x equals 0, that means that whole term there would be equal to 0, so it disappears, and I would have 4y equals 24. Then I solve it by dividing by 4, and that would give me y equals 6. Then, going back to the start, if y is equal to 0, 4y would equal nothing, and I would have minus 3x equals 24. Dividing by negative 3, we get x is equal to negative 8. Sketching that, we're going to put on here that y is equal to 6. We just want to put it in roughly the right spot there. Y is equal to 6. And on the x-axis, x is equal to negative 8. And then join it up. That is question 2. We want to sketch two things here. Y is equal to negative 2. And then y is equal to negative 3x. Y is equal to negative 2. When it's y equals a number, it means it's going to be a horizontal line going through where y is equal to negative 2. So it looks like that. Then for b, y is equal to negative 3x. Because of the x in the second half of that equation, this is going to be a sloping line that has a gradient of negative 3 and a y-intercept of 0. So we're going to start at the origin, and then we're going to rise 3 and run 1 to the negative side. So 1, 2, 3 up, 1 to the negative side would put my second point here, and that would be my line. Labeling the point would be negative 1, 3. Okay, so after that quick recap, we now want to be able to find equations of lines. This may mean that we'll have to calculate gradients, and to do that we can either use the good old-fashioned m equals rise over run, or we can use 2 points that we have on a graph and find the gradient using m equals y2 take y1 over x2 take x1, which is really just another version of rise over run, because it's the changing in the y over the change in the x, which is rise over run. The gradient intercept form of a straight line, we've talked about this in previous times, that y is equal to mx plus c, where m is the gradient and c is the coordinate of the y-intercept. So that's why finding the gradient is so helpful. So if you have the gradient and we have one other point, we can find the equation of a line using this formula here. I like to call this the point gradient formula, because you have a gradient and then these two values here will be the point that you have been given or can find from a graph. So often in the last dot point there, it says to find the equation, we might have to use both formulas. You might have to use this formula to find the gradient first, and then put it into the point gradient formula to find the equation of the line. On the next page, the word collinear. Collinear points are points that are on the same line. So if points A, B, and C are collinear, then the gradient of AB would be the same as the gradient of BC. So if a straight line like this, a bit wobbly, but you get my point. The points A, B, and C are randomly spaced along that, and they would all have the same gradient because they're all on that same line. So that means they're collinear points. Okay, in the example number 1, we want to find the gradient of the line joining, and we have 2 points there. So to find the gradient from 2 points, we use m equals y2 take y1 over x2 take x1. Now the x1s and x2s, those things, they come from the point that you've been given. Each point always has an x and a y value. So in the first point, we tend to call it x1, y1. And in the second point, we call it x2, y2. And then we sub in. y2 is negative 2, and then minus from the formula, y1, which is 6, over x2, which is 3, minus x1, which is minus 1. So you can then type that into your calculator or however you want to work that out, and the gradient is equal to negative 2. Question 2, find the equation of the following straight lines. Now this is pretty much the same as the last question, except that it's been given in graphical form. But really, I just have 1 point here and 1 point there. So let's start by finding the gradient. The gradient is y2 take y1 over x2 take x1. You could make a triangle and do a rise over run if you'd like. I'm going to call this x1, y1, x2, y2, and sub in. So y2 is 1 minus y1, which is 16, over x2, which is 0, minus x1, which is 3. So that makes negative 15 over negative 3, so that comes out as m equals 5. Now I could, I'm asked to find the equation here, so there's 2 possible ways to find the equation from here. If you are lucky enough that one of the points that you've been given is the y-intercept, so this point that I'm putting the box around, this is the y-intercept because it is on the y-axis. If you are given that point, that means that that 1 in that point there, that is the value of c in the y equals mx plus c equation of a straight line that we have. And so all I would need to do is sub in that m is equal to 5, so y equals 5x plus 1, because that was my y-intercept. However, we're not always that lucky that we're given the y-intercept on the graph there. This second one, neither of those points are on the y-axis. I don't know what this value is here, so I'll have to do this one a little bit differently in the second part of the question. I'm still going to start by finding the gradient using this formula. So let's label this x1, y1, x2, y2, and then sub in. y2 is minus 5 minus y1, which is 1, over x2, which is 1, minus x1, which is minus 1. Minus 6 over 2 makes negative 3. So there's my gradient. But now, because I don't have a y-intercept, I can't use the y equals mx plus c. I need to use what we call the point gradient formula, which is this one. This would also have worked for the part A of this question up here. You could have just always used this formula. It would have just taken a little bit more working out. Okay, so subbing in from, I'll use the same x1 and y1 that I have up here. I'll have y minus y1 is 1 equals m, which is minus 3, bracket, x minus x1, which is minus 1. So 2 minuses makes that plus 1. Okay, now to get this looking a bit nicer, we're going to expand out the right-hand side, which is negative 3x minus 3, and then the negative 1, we're going to move that across the other side. So y equals minus 3x. When I add 1 to the minus 3, I get negative 2, and that's the equation of my line. Question 3. Find the equation of the line passing through the 2 points. Okay, again, this is like the last question that I did, but this time I don't have a graph to go with it. But my 2 points are still here, x1, y1, x2, y2. And I want to find the equation, which means I want the gradient first. And then I'll sub it into the point gradient formula. So y2 is 9 minus minus 3, so plus 3, over x2, which is 6 minus 2. That makes 12 over 4, which is equal to 3. Then into the point gradient formula to find the equation. So using the x1, y1 that I've already labelled, that would be y minus minus 3, so plus 3, equals m, which I worked out was 3, x minus x1, which is 2. Expand the right-hand side, which is 3x minus 6, and then get the y by itself by subtracting the 3 across the other side. So that will make a negative 9. Question 4. This is just, again, another way of giving the same bits of information. This is in a table, but this represents a point, and this represents a second point. So the first point, I can call this x1, y1, and this can be my x2, y2, and then I can still do it in the same manner. So even though these questions all look slightly different, each one of them, I need to find the gradient using this formula, and then find the equation, usually using the point gradient formula. So y2 is going to be minus 8 minus minus 4, so plus 4, over x2, which is 6, minus 4. So that equals negative 2. Then the point gradient formula yet again, just like that. So it would be y minus minus 4 plus 4, that makes, equals minus 2 bracket x minus 4 close bracket. Expand the right-hand side, and then get the y by itself by subtracting the 4. So 8 minus 4 makes 4. So the final equation is y equals minus 2x plus 4. So that means you can now do exercise 1F, and there is also a progress quiz in your textbook that will go over everything that we've learnt so far in this topic.